In this lesson, we look at the GPS GTU7 module. This software module interfaces to a fairly inexpensive GTU7 GPS hardware module I found on the web. The hardware module has a serial UART interface that provides satellite and location info via messages in text format. If you just power up the GPS module, it will start to send messages over the serial interface with this information. You can also send commands to the module, but I haven't done that. The hardware module also has a discrete output that provides a 1 pulse per second signal. This signal is very precise, and it is common for GPS modules. So here's a picture of the hardware. These wires here are for the UART interface and the 1 pulse per second signal. And this antenna came with the unit, and it connects to the module with a very tiny RF connector right here. So I was wondering what I could do for a demo. I am stationary at my desk, so my position is not very interesting. But the satellites are moving, so I thought it would be interesting to take the satellite information and plot locations of satellites in the sky on the console. Now, the console is crude, it's just text, and I don't have a nice graphics display from my board. But the console interface works, and you'll see it shortly. And this module supports these console commands here, and we'll look at those shortly. Before I get started, I'll mention this. I did not want the hardware model number, the GTU7, in the software APIs. So the file names use the term GPS GTU7, but the software just uses the term GPS. So that's a little violation of my module pattern. Here we see the major interactions between the GPS module and others, and there are three. First, the GPS module has some console commands, so it interacts with the command module in the normal way. The module also uses the TTYS module to communicate with the GPS hardware module. And finally, it uses a timer in a way we'll see when we look at the implementation. Very briefly, this is used to detect when satellites are no longer visible. Let's look at the GPS API in the header file. The API is very straightforward. The only configuration parameter is which TTY instance to use. And then here are the core interface functions, and it uses all four. There are no other APIs, but if we were using this module in a real product, there would certainly be APIs to get the current state, the current position and so forth. But since we're just using it in a demo, there's no need for that. Now let's look at the implementation. I'm going to be pretty brief here. Much of this code is parsing messages received from the hardware module and plotting satellites on the console. It might be interesting to some of you, but it isn't very specific to embedded systems. Maybe it would be useful to read if you're trying to improve your knowledge of C. So let's look at this. One thing I always look for is the state, and here it is, state of the module. A couple things. There is a buffer here used to build up messages received from the hardware module, and then here is information about the satellites that are being reported. Here is information about the console commands that's provided to the command module on startup. A lot of modules have this. Here is the get default config. Really the only parameter is the TTYS or UART instance, and it's UART6. When we start a module, we get a timer. We call it the cleanup timer, and we'll see how that's used in just a minute. Here is the run API, and basically every time it runs, it looks to the TTYS module to see if there's a character, an input character, and normally it uses this to build up the messages in a buffer from the hardware module. If it gets a end of line indication, which is right here, it processes that message by calling this function, which we'll see in a minute. Here are the command handlers, console command handlers. There's a status command and a map command. Here is the message to process a message, or the function to process a message. And this is string processing in C. C is not the finest language to do string processing, but there has been much of it done over the years. And it's something you just get used to, and everyone sort of develops their own tricks and patterns of how they do string processing in C. It's also a good source of bugs, to be honest. I'll keep going through all of that. Then here is the display function that prints the information on the console. And there's some trigonometry in here, these lines, where it is taking the satellite information in the sky and projecting it onto a two-dimensional plane so it can be displayed. And finally, here is the timer callback, and we need this because when a satellite is no longer visible, the hardware module doesn't tell us this satellite is gone. It just stops reporting it. So this code goes through each satellite that we have information about, and it checks how long it's been since it's last been reported, and that's what this if statement is doing. And if it's been too long, it removes that satellite from the state information. You'll notice it returns CB restart, which tells the timer module to start this timer again, and so the callback is periodic. Here we are at the console. First, let's look at the commands that the GPS module provides. And you can see it provides a status and map command. Let's do GPS status. And what it shows us here is the list of satellites being reported. Now, if you look at the implementation code, you'll see that the code maps satellite numbers to a single character. And so it maps the satellite numbers to the characters 0 through 9, and then A through Z. And you can see those in the first column. And then for every satellite, there is the location in the sky of where it's seen. And this last part, last report, is how long it's been since that satellite was reported. And you can see they're all well less than a second. Currently, only satellites from the original GPS system are tracked, although the module seems to recognize other satellite systems. So now let's turn on the map. So this map represents the sky, and up is north, and to the right is east, and of course to the bottom is south, and so on. When a satellite moves in this grid, for instance, let's say the satellite H moved to the right, then H would be printed on this next position, but the H would be left here as well, where it used to be. And that is used to show movement in a way, although as satellites cross paths, information is lost. But anyhow, since I brought this up, the satellite E has moved one position, and there it is. Things move slowly. The satellites move slowly in the sky, and also this grid is pretty low resolution, so it takes some movement before you notice it in this grid. I wanted to provide a little more information about this satellite tracking, since I thought it was kind of cool. Now here is a snapshot of the GPS map on the console after I let it run for several hours. You can see lots of satellite paths keeping in mind that data gets overwritten as the satellite paths cross. There are two things to notice. First, the location of the satellites are in a circle. The reason for this is we are taking satellite positions in the sky and then projecting them down to a two-dimensional plane. If you imagine this, I think it will be clear why we see the circle. You'll also see a blank area near the top. I think the reason for that is as follows. I live sort of on the side of a hill. So to the north of the building I live, the hill rises and there's another building there. So I think that to the north, the GPS module cannot see satellites close to the horizon. The hill is in the way. Maybe it's something else, but that made sense to me. Now, one thing you might find of interest is this. There's a website that shows the satellite positions, and it seems to agree with this demo. Should not have been surprising, but it was a little bit. It was satisfying that the data matches. If you do go to this website and want to compare these maps with that website, I suggest you uncheck all of the selection options except the GPS operational satellites. And that way you're comparing the same set of satellites. So I thought this was fun, and if I get a nice display, with the color maybe, I would like to do a nicer job on this. But even with the console, it's interesting. So that's it for the GPS module, and thanks for watching.